Thanks, Paul. That was a great presentation. All right, next up, we have Carlos Femmer from HDR. He'll be doing a presentation on enhancing bridge inspections, harnessing the power of drones for safer infrastructure. Carlos holds the position of Director of Data Acquisition at HDR, overseeing the company's data acquisition and unmanned aircraft system initiatives across various market sectors. Before his role at HDR, Carlos held several leadership positions at John Chance Land Surveys and Fugaro, including VP, COO, and President. There, he managed numerous aspects of the company's growth, innovation, and strategic direction, particularly within their land survey and airborne units. With a professional journey spanning over 2 decades, Carlos has led teams responsible for surveying massive stretches of transmission lines, pipelines, and railways, accumulating tens of thousands of miles. Internationally, he has spearheaded drone operations in Australia and Canada. Carlos also played a pivotal role in establishing a drone program for the Navy's survey division, encompassing everything from SOP creation, registration within the Department of Defense, and drone procurement, to executing pilot projects and offering hands-on training. Notably, Carlos made history as a first commercial drone pilot to inspect the Golden Gate Bridge and was among the pioneers in conducting the first commercial drone missions in the Grand Canyon. With that, I'll hand it over to Carlos.
Hey, good morning or good afternoon. So we'll get started. My name's Carlos Femmer, like Alicia just mentioned, and we're going to dive right in. So bridge inspections, we think the game-changing technology mix is drones, AI, reality mesh, survey. My background is survey, so every project we take on, we tend to set survey control, and then we build on it. So we found that it might be a little more expensive to do, but the end result is, what we want to get out of it. So today we're going to talk about some case studies. We're going to look at Golden Gate Bridge, Grand River Bridge inspection in Michigan, and then a project, the River Bridge inspection in Pennsylvania. So to start off with the Golden Gate Bridge, we provided inspection services since 2015. We conducted the first ever close-up visual inspection of the main suspension span towers in 2018, and then drone inspections piloted in parallel for a section of the bridge in 2021. So what we appreciate with some of the clients is they're really forward-thinking, saying, okay, how do we use a tool and complement it? And our approach was we don't want to just depend on it. It was a project where we did in parallel. This was done, blind test done manually, and between the two, we're going to talk about some of the results that we got out of it shortly. So planning and approvals, mission planning, we talked about project area review. We looked at like the capture goals and determination, airspace permission, identification, risk, equipment, flight plan, weather, schedule. All those things were considered, but the reality is when we looked at the project, when we got all the permissions and we went to the FAA, it still took a couple weeks, and they were saying, well, because it's never been approved, we didn't know, how to approve this project. So sometimes when you're doing the first one and even provide the appropriate documentation, it still takes a little while for it to get approved finally. Equipment selection, that's another thing we'll talk about. We went with plan A, B, and C. When we looked at all of the factors, environmental factors, obviously Golden Gate has wind. That was a big concern of ours. That was the number one concern. So we brought a BFD drone. This is about a $150,000 drone, can handle winds up to 35 miles an hour. And what happened is as we started to fly it, the seagulls took it down. So we're like, okay, we're solid for the wind. And then we get it up in the air, and then just like 20 seagulls start dive bombing. And I'm like, man, that's not cool. Went hide behind a rock, did it again. Seagulls couldn't see it. They started circling. As soon as it was visible, they came and attacked it again. So I was like, okay, that's plan A's out. So we're going to plan B. So we looked at another drone. One of our conditions was staying 50 feet off of the structure. And the second component didn't work out as great. So plan C was Skydio. So thank God we had that platform. Key approvals, before I get into that, we talked about Golden Gate Bridge Authority, Caltrans, FAA, Coast Guard. We coordinated with the Coast Guard. We're flying. They still flew helicopters close, so that didn't work out well too. So whenever we looked at it, you have to yield to manned aircraft. So overall, I think it ended up being a success. We talked about the challenges and adjustments. Because of the seagulls, we ended up going with the drone. But this was one where they said you can't be within 50 feet. So we took a timeout, went regroup, and said, listen, if we're going to do this, we need to be within 3 foot of the structure. So they said, okay, we'll allow it as long as we don't go above the bridge deck. So again, a lot of that planning, coordination, talking to the client, we got the permission, and then we went perform the work, and it worked as expected. So data comparison, traditional versus UAS collected. Still frames from the video were extracted, matched to the applicable bridge section, and included in the completed inspection form. So we took the drone data and put it on the traditional reports that Golden Gate Bridge Authority in California is used to. Comparative analysis performed between the reports, and what we found was condition, state of truss members were similar. The identification of gusset plates, pack rust was similar. Again, this was a blind test. So traditional rope inspection, drone inspection, and then those were compared independently. And what was nice is those values came out the same, which was good to hear for the value of drones in the industry. The thing that didn't come out the same was the paint condition state varied. Wasn't a big deal to our inspectors. But we think we could be attributed to somebody's rappelled down, backed off, taking a picture or looking at it, versus a drone 20 foot away and lighting and exposure. So that could have been part of it too, but it wasn't as big of a component that we were concerned about. So lessons learned, approval, processes, efficiencies. I think the first time you do it takes a while. The second time you do it, it's a lot better. In the case of like the Grand Canyon, when we got that permission, that took almost a month to get approval. And then after that, the next time we went on the second deployment was a week or less. So, that's part of to be expected for approvals. Equipment selection, looking at wind resistance versus precision, workflow improvements, timestamp syncing, footage labeling. We had some good lessons learned after the project, and then equipment vendor collaboration, being able to put prototype options on the drone. We have good relationships with a lot of these vendors. We've provided feedback to Skydio as well, saying this is what we would like to see. I know last week they released the X10 Skydio, 61 megapixels, so we're super pumped about what that's going to offer. But as the industry keeps on improving, that's what's going to come as well. Pivoting to US 131 Grand Rivers. This was the first official bridge inspection for Michigan DOT. Part of it was to provide routine visual and element level inspections. So some of the challenges, if you look at the picture here, is high traffic volume, entrance, exit ramps, structure width, and then heavily populated surrounding areas. The other part too is because of the span, getting the equipment on the side and a bucket to come underneath just couldn't reach. So the drone, because of the equipment and whatnot, offered a good alternative for all of the variables that were listed. So we did a total of 18 flights in 3 spans on boat structures from the riverbanks. We used a secondary drone. That's kind of like Paul showed earlier. You want to capture it overall, capture the side. You could get the digital twin of the area, but then you want to complement that with the close-up and photo inspections. And then we piloted the flights of the structure in a sweeping fashion, working with Mike, who's in the room with Bentley, helped what's the best capture guide. If you capture it wrong and you don't have the appropriate overlap, it could impact your result. So, following best practice guidance on that is critical. So project approach, scope development with client, sitting down and understanding what their goals were was important. Planning and logistics, site access and coordination, and then we kind of used the 5 critical rules for planning drone inspections. If you look at the top right image, those were the 2 spans and kind of what we did for some of the flight patterns, and the area of interest was on the bottom right. So project delivery, site visit and stakeholder meeting, inspection and flight planning, We provided the data collection. And then on the reporting, review video data files, assemble caption still photos, and then summarize observation and conditions. Again, even on this one, at the time, we were hoping we can gather some good information from it, and it worked out as expected. So on the element level conditions and the visual conditions, it checked all the boxes on those. So we knocked it out the park on that front. Just talking about the lessons learned, the technical checks. This was 5 years ago, and drones have evolved. This was a DJI, has a magnetometer, has interference from the drone. As you get into new drones, you want to start looking at new capability. Like the Skydio flies off of visual, 360 visual, doesn't have the electronic interference that we're seeing here. The other part is GPS denied environments. When we went under the bridge deck, we were in GPS mode, turned it into ADI mode, which is just, don't have the GPS, because the other part too that you can get in trouble is if you're going under a bridge deck in a GPS denied environment, you don't toggle it off, it might give you a latency. And if you have wind, like in this case, the wind was streaming underneath the bridge, it can cause you to wreck before you get control again. So it's a science, but it's one that we were ready for. So we went into the ADI mode, captured the data that was required, and it worked great. Weather and site conditions, and then camera and unit operations. On this one, we had a drone on a camera on top where we're taking some telescopic photos. So we stayed a good distance from it. Now with new drones as of today, if we were going to go redo that project, we'd probably go with a Skydio, GPS denied. You don't have to worry about toggling it from GPS to ADI. Go underneath it, take the photos, you can point straight up. So a lot of things that we had to contend with on this project's not an issue anymore with the right platform. And then this was an ASTRO cost comparison saying, okay, manual inspections, 4,600, UAS 1,200. We found similar, we do a lot of dam inspections as well. Those are in the range of 25 to 50K and 100,000 to 200,000. So what we found on some of the dam inspections is we're kind of seeing that 75% cost savings as well, just bringing in some water to the transportation world. And then lastly, we're going to talk about the Susquehanna River Bridge drone inspection. So this is nearly 1 mile long, 4,600 feet, 14 piers with a maximum height of approximately 175 feet, 76-foot end-to-end drop from 516 to 440. What we ended up doing is doing the piers, and then we worked with Mike Burkasey with Bentley and had a nice combination where he was able to get the bridge deck, and then we combined that data set together. So this was kind of a hybrid test pilot project, and it's pretty cool. So I think he's going to start the 2 videos here. If we go back one, let's see, right here. If we click on those 2, and the one on the right, please. There we go. So this is kind of what we're looking at for these pier decks. The video on the left is what the drone sees, and the video on the right is what you see from the ground. These piers are 175 foot, so if you're flying, I don't know if you ever flew and your hands get sweaty and stuff, like, man, don't wreck, those type of things. This is one where just the perception of how high it is, you start to get nervous. But what's cool is you tell it what your bottom is, what your ceiling, and the 4 corners, and you say go. And it'll go and put all of this in an exploration mode, put it in memory, and then you say go, and it'll go collect 2,000 photos on its own, and you're just watching it and changing batteries. So it's a nice way, because it does the visual. As you saw here, it goes underneath the bridge deck. Not concerned about GPS losing that information, not worried about it crashing. Just a new tool. And then you can see again where we're standing from the ground. Now, in the end, we're going to see where this comes together. But, and this is something where taking the top deck and the bridge and combining it together, we're able to blend the photos. If we look at this bridge was being constructed at the time, so this is over multi-years. 1 year it was captured, there was dirt. Next year it was captured, they poured the caisson and the piers. then they're building up the piers, then they're laying the deck. So what's nice about this is bringing it into this I-twin environment and being able to compare what was it like before when it just had the case on and this year, and let me see what the finished product looks like, or let me see what this is. So if we're looking at like 4D phasing and construction and progress monitoring, it's a tremendous tool. I was talking to Mike earlier, and one of his comments was we tested out like the drone in the box on a project in Florida at SunTrax, and because of the FAA rules, you can't fly without beyond visual line of sight. So our thing is we tested it inside of a building. We had a big warehouse we were constructing. We just let it go and let it run daily. So something like this, where now this is becoming more mainstream with beyond visual line of sight, where you can take it up at a site, launch it, go perform this capture, come back and land, update the data. It'd bring the cost way down and give you progress monitoring from your home station. So that's something else we're looking at heavily. We had a presentation yesterday on IoT, being able to put sensors on it. And I don't think this video is playing, but what you're able to do on there too is on a bridge, put some sensors, click on it, see real-time data, see graphs, all of those components there as well. There we go. So there's the video playing. Yeah, so blending, kind of like Paul showed before, having all of these components where you have it laid out, and then adding your engineering support into it as well, and being able to use that information. You'll see a picture of it here shortly. So you could take your engineering drawings, overlay it onto your drone topographic data, your reality mesh, tie it to survey control, and then, like we talked about before, do multiple flights and show the progress of those as well. Here's a case where you can see, some proposed sensors that are being put on onto the pier. So we have the actual and then the engineered, and see if those kind of match together. Nice part about it is everything's web-based here, so you're not having to just have it on the desktop, being able to see it through the web and share it with the teams across across the state or whatnot. So we were showing a presentation yesterday of inclinometers showing, okay, here's a landslide, and here's where it's shearing. It's shearing between 18 feet and 23 feet. That type of data. So IoT could be an inclinometer. It could be a weir flow sensor on a dam, or any kind of sensors that are on a bridge as well. They're all integrated. So project outcomes: improved safety, time and cost savings, unrivaled accuracy. I want to qualify that statement too, because you could have a total station take some very accurate millimeter shots. You could have a LiDAR, but if you're crossing a river, your range is limited. So when we say unrivaled accuracy, it's for cost-effective unrivaled accuracy. Because if you have survey control tied to this, having 1 centimeter data, 2 centimeter vertical or whatnot is tremendous. So, what's the cost for that particular asset you're covering? Comprehensive asset management solution and a long-term digital twin model that can evolve over time. So in Utah, we've done some work here. We created models. So the way we're using drones in Utah is we create models to estimate quantities of potholes, capturing high-resolution imagery of hard-to-reach bearing seats, deck undersides, basic detection for size and density, and then to date, we captured about over 99 bridges with drones in Utah. Here's an example where it's Ogden 24th Street Bridge. It's a mapping mission. You come into here, and this is just a zoom in. One component there too is it doesn't have to be tied to control. Depending on what you're trying to do, you get some great measurements. Our old school method is we'll go lay out a ruler and we'll place it on both sides of the bridge deck, and then we'll fly it. So we can get some accurate measurements that are relative, that are more than sufficient. So you don't have to, invest in GPS in certain projects. If this is what you're trying to do is quantities, there's your QC of it and how you want to use it, and you don't need a GPS or RTK for it. So the big picture, here's an example. So let's say you have sensors on a bridge, or somebody notices something and they call you in the middle of the night. You can deploy a drone autonomously, you could use AI, and then you could share it with the end user. So another thing that Paul was showing with the virtual, but here's an example where we took that CSVT bridge, took 14 piers, created a digital twin of those, and now what we're able to do is take all of those that are 175 foot high, get, let's say that there was a crack on that pier. We get a call in a different state. Somebody could come on, load up the VR, and this is now looking at that environment. So I can access any of the 14 piers, even in the middle of the river, from a headset. Now I'm looking at it from the bottom. I'm coming across, you can look at the sun angles, how does it impact, and visualize it. And then lastly, coming over to, showing kind of the cars and traffic that are animated. Coming to the pier, and now that, let's say that it's 100 feet in the air. Well, I'm gonna time warp to that level and put it at eye range, and I'm gonna inspect it at, as if I'm on the ground. So this is kind of the future that we see with it, regardless of the size of the bridge, regardless of how tall, how complex, being able to have that information at your fingertips from your home is the key. So appreciate the time today, and if you have any questions. Yeah, so if there's no questions, I'm going to hand it back to Alicia, and appreciate it. Thank you all.